My name is Rohan, and Rick's going to be controlling the screen.
Yeah, so here's the architecture real quick, folks. This is a lab hosted out of our Sunnyvale campus a couple miles down the road. We have our 5-stage cloths, so very popular in the concept of campus fabric. So a couple of access switches terminating VTEPs, VXLAN tunnels on our 4400s, okay? We have our layer 3 boundary at the access layer, and then we've got a lean distribution layer at the 5120, just very high-speed router in and out. You could call us multipath, QoS. And then our core, which is a 9204, is acting as a border gateway. So it's terminating VXLAN tunnels and talking to a northbound SRX firewall in a cluster. Okay, so that's what we're going to build. So let me pop out of here.
Awesome. So we have the two EX9200s. We are no longer in the business of just access switches. You know, we've transitioned from our small pizza boxes, EX switches, all the way to modular switches, EX9200s, TFX 10Ks. You can onboard them. All of those are cloud-ready devices. So ZTP works as flawlessly as it would work on a pizza box, right?
So I'm going to go ahead and bring up a session into our virtual desktops here.
Right. So we have two desktops connected to each of the two access switches. These access switches, think of them as IDFs. We have an access point, a MIST AP connected to one of the access switches. And in this demo, we'll be focusing on a standalone access switch, but they might as well be a stack, you know, like maximum you can do 10 members. So the latest EX4100 that we introduced over the summer that can do up to 10 members in a stack. So you might as well use that in the access. While we ready ourselves for the demo, we'll basically be we'll be showing you org topologies today, as Rick was mentioning earlier. So here what we have on the screen are 6 different nodes that we showcased you earlier. These will be a part of the fabric, 2 cores, 2 distributions, 2 access. And Rick, do you want to jump into the campus fabric here? So basically, what we want to show you today is how seamless these things are, right? We don't claim to be the first ones to do this in the industry, but what we do claim is that it's brain dead simple. Literally anyone can do it, as long as you provide us just the basic values like VLANs and do you want to segment your network. It's just step by step, 5 steps, and that's pretty much it. So Rick, before you jump into the organization level, I want you to go back to the site topology. So what we have here are 2 kinds of topologies: org topologies and site topologies. So you had a question earlier: can you do IPCLO, GBP on a site topology? Yes, nothing changes. A site topology is a site. It's a fluid concept, right? Think of this Santa Clara Hilton as one site, right? You can run an IPCLO network in this. But what if you had multiple Hilton buildings, that are probably, in a radius of 5 miles with each other, and you have 2 core devices, and you want to have each Hilton as one pod? That's what we're trying to achieve through org topology. So when we came here last year, when we met with the delegates, we took some learnings. We took some learnings from the customers. So we transitioned from not only just site topologies, but we added a layer of org topologies on top of that. So Rick, if you don't mind clicking on site topologies for me, I just want to show the 3 options that we have within actually configure campus fabric. So we showcase you 3 topologies: EVPN multi-homing for the the small use case. You want to transition from a proprietary technology. You want to transition from a plain L2 spanning tree technology or an MC lag. EVPN multi-homing is for you. So you have 2 devices in collapsed core and then a bunch of access layer that's not running EVPN VXLAN. Then we have campus fabric core distribution and IPCLO. So within site topologies, you have all 3 options, but our focus for today will be org topologies. But I just wanted to sort of differentiate there that it doesn't really matter. Org topologies are built for scale. So here you have 2 options, topology types. One is campus fabric core distribution. We've spoken about it multiple times already. If your core and distribution in campus fabric core distribution are running EVPN VXLAN, but your access is plain vanilla running just pure LSCP. So if you have, and that's where the boatload of the devices are, right? So you can have those access devices as non-Juniper devices, and that is Campus Fabric core distribution. The last one is IPCLO, which is the focus for today. And all of these devices will be running EVP and VXLAN. You're extending your VXLAN all the way to the edge. So your cameras, your wired network, everything, your access points are connected to the access devices. Two options here, routed at distribution or routed at edge. By default, we're routing at the edge, at the access. What does that mean? Well, the gateways for those end hosts, for those APs, for those desktops are at the edge. But as Rick mentioned earlier, if you have devices at the edge that are, that cannot scale to an extent, let's say you want 100,000 clients, your access devices may not scale. So you can move the gateways a notch up to distribution, and you can have the gateways for those end hosts at the middle layer, which is the distribution. Topology settings, very standard. What's the BGP AS? We use that for underlay and overlay. You can do 2 byte or 4 byte, and then very important, subnet. Again, all of these values are default. You don't have to change it. If you wouldn't like to, most customers do not, but it's totally up to you. The subnet is essentially, you give us one subnet, we take that and slice into multiple /31s for your underlay IP addresses. So today we are going to show you 6 devices. You might as well do 60, and you don't have to worry about any of your underlay IP address peering there.
Just a quick question. AJ Murray here. For this demo and for any deployment, are these switches clean out of the box? You
They
don't
are.
have to do any bootstrapping?
They are, absolutely. So one thing that we're not showing you here, but that doesn't change anything, is all of these devices are cloud-ready devices, as I said, right? So you literally take out your mobile app, Mist AI app, scan the QR code, and just onboard them. That's pretty much. And once they're onboarded, you're not touching them. You're not doing anything on those devices. You're not adding a single line of configuration in there.
Nice.
They are basically in non-configured mode, so you're not, by default, they're not managed, and you can go hit apply the configuration, review the configuration, and then maybe apply manage configuration.
What's also important to understand is that the devices just need to be part of the organization. They actually don't have to be online.
Oh.
So
Yeah.
if in the world of supply chain, where you might not be able to have the devices readily available, as long as they've been pulled into the org, you can build the fabric. So you could have your templates built, you could build the fabric, and then you apply it when you're ready, right? So they don't have to be online for this function to work.
And I'll touch upon this point in a second again, but here, plain that simple, select 2 core devices, and then we're talking org topology, so we're talking pods, right? A pod is essentially one site, one building. It is realistically not possible to have 20 buildings, 20 sites, and have the access connect to all the distribution devices in those 20 sites, because that's not how you scale, right? That's where the pod concept comes in, right? So you're connecting 2 access devices or 20 access devices. All you have to worry about is just peering them up to the distribution in that pod, in that site. So as the example I gave earlier, in this Santa Clara Hilton, you're connecting your IDFs to your MDFs, and that's pretty much it. You're not spanning them across the campus. So give it a name, assign, select 2 distributions. We'll start with 1 access, and then we'll go from there. Rick, can you show us the service block here on
Yes.
the top?
Yep.
So if you scroll up, we spoke about service block earlier. So what exactly is service block? Why do you need it, right? Well, service block has traditionally been a data center concept, right? We are expecting these core devices to encapsulate and decapsulate the traffic. Remember, we talk about VXLAN headers. So when the traffic actually hits the access, it is encapsulated. The plain layer 2 packet is encapsulated in a VXLAN header. That header is has to be decapsulated somewhere if you're talking public internet, right? That happens by default on the core, right? So you're talking everything, you're basically talking all the load on the core devices. But if you want to offload that, if you want to keep the core devices lean, we call them lean spines in the data center world, you want to keep them lean, you want to offload that functionality over to another pod or service block, you can have up to 2 border leaves there. So Rick, if you click on them, it doesn't change anything on select switches. It doesn't change anything from a customer's perspective. They're just selecting 2 more devices as a service block. We take care of all of the configuration that is meant to be on the border leaf. And that exactly just leaves the core devices as lean. They're just responsible for passing traffic between the leaf devices and between the end host, right? But to keep things simple, we're not going to do the service block today, and we're going to proceed with what we have right now. Step 3, configure your networks. Tell us what VLAN definitions you have, right? There are 2 ways to go about it. A very simple way is to build a template outside of the Campus Fabric workflow, and we'll show you how simple that is. Build a template, configure as many VLANs, as many networks as you have there, and then reuse them in as many places as you'd like, right? So that's exactly what Rick did here. He clicked on Add Existing Network, import the VLANs, or you can go and create new networks and go from there. One thing that you would have noticed is that there's a block called Other IP Configuration. We're not asking you to do any IP addressing. All we're asking is just give us a subnet. We take care of the IP addressing. So your IRB/SVIs, as they call it, on your so your end hosts need a gateway. Those gateways right now, because we told them route at the access at the edge, we automatically do the IP addressing for you. All you gave us was a subnet. So if you click on VLAN 1033 rig for me, you provided a subnet there, and that's pretty much, we took care of the IP addressing. So we're doing anycast IP addressing, which is basically one IP address on all the leaves in the access. So we're saving you the address space, right? So think if you had 254 access leaves, we're not consuming a /24. We're just taking one IP address for VLAN 10 as an example and spanning that across the entire leaves, all the leaves.
And if you had different, if you use a .254 as a gateways versus .1, you could change this as well, right?
Of course.
So
yeah, you have full control over that. But for most of the users, do you worry about that? Probably not. So we're doing some defaults for you, but you can come and change that. The last and final step here is VRF. Do you care about segmentation in your network on a layer 3 level, right? We're not talking micro segmentation. We're talking segmentation between VLANs, right? Think of a healthcare environment. Privacy and security is of the utmost importance, right? We really want our corporate traffic to be segmented from our guest traffic, right? If anything, you've gone through Juno's configuration, you can understand it is complicated because you have to add interfaces, you have to add VLANs. We're making it simple for you. Just create an instance, add different VLANs to different instances. If you'd like to add extra routes to it, like a default route or something, that option is available for you as well.
In this case, we are routing between the campus fabric and the firewall. Right. We're using BGP to route. But if the firewall was the default router for the entire subnet for the network, which is very possible, that layer 3 boundaries at the firewall, we would just put the default route here and just pass the traffic up through as layer 2.
Yeah. Last and final step, right? Each step leads to the next one. And as I said earlier, it's pretty simple, right? So in this step, we're asking you to basically tell us how your connections are, right? You've built the core distribution and access. You've racked and stacked them. So there are 2 ways to go about it. One is what we have here. We have the devices in the lab. We've racked and stacked them. Rick knows how the cables are connected, so he's plugging in the ports right now. The other way, something that we touched upon earlier, and I'll go back there, is supply chain problems, right? We've gone through them for the last 2 years, right? Let's say you purchased Juniper gear, you purchased, you had a purchase order. What you get on that is an activation code for the entire order. You plug that into the MIST dashboard. What it does is brings up 6 or 60, however many devices you had. It creates an instance of each of those devices with that exact platform. So while the devices haven't even shipped, you can come here and build a fabric. And because the fabric isn't even racked and stacked, you can choose your own ports, whatever you'd like, you can do that. And then once the devices are shipped, racked and stacked, you can hit apply configuration and go from there. Last step, verification. Pretty standard, right? Rick, can you actually go and start the ping from the desktop to access to?
Yes, sure.
From an access layer standpoint and device onboarding, are the ports essentially the device facing ports? Are they essentially unconfigured? And then when the device gets onboarded, if you're using Radius or whatever, it'll push whatever VLAN and et cetera to the port.
Absolutely. Okay. Absolutely.
So the end device facing ports can be configured using templatization. We spoke a little bit about dynamic port configurations in the start of the session, where we said if there are devices that we can identify, we can put them on the right configuration for you automatically. We can go into the switch templates briefly in our breakout session as well. So this will help you bring the fabric up. The templates are already built, and that can either be your standardized saying my ports 1 to 10 are AP ports, 11 to 20 are camera, or you can say whenever you see this condition, give it the camera port.
Right.
So
okay.
we have both.
That's what I was wondering.
Yep.
Okay.
Got it. Yeah.
So as we saw here, if you show us the secure CRT there, before the configuration was pushed, Rick here is trying to ping from his desktop, which is already hooked up, to the access switch that we just brought in, to 1.1, right? We saw that the pings weren't working. All the configuration from the core to the distribution to the access was pushed. The only thing that we did not show you here, that's something that we already pre-did and we'll review the configuration, was the configuration between the core and the router itself, the MX router, which is something we can show you. All of that is again done through the UI. No CLI configuration required here, at least for all the devices that are managed for the fabric, right? So we can see here that the desktop 2 can ping the internet. And at this point, what I want to showcase is, Rick, if you click on the access to for me on the configuration, if you click on access, if you scroll down, click on access to and scroll down, we can see the BGP neighborship. All of that is established. You can see the stats here. You can log into the remote shell. So for all the CLI savvy users, we don't stop you from logging into the shell. You can click on the remote shell. You can do whatever you'd like right from the Mist UI. And as you can see here, of course, BGP is up and running. Can you do a show configuration pipe display inheritance pipe display set? And we want to show you all the configuration that was pushed through the UI without the user typing a single CLI statement in there.
All right, let's go to the other switch here. If you want to do that.
Thank you.
No problem. We also have an AP connected to Access 1, so we're gonna pull Access 1 into the build. We've got Access 2 built. Access 2 is pinging the internet, routing through the fabric. We have an AP that's connected, waiting for accessibility. So this is a full stack because we also have, by the way, our SRX managed.
Right.
So it's a full stack type of approach here. We don't spend a lot of time on SRX here. That is our WAN assurance product, obviously. But if you want me to add second access switch?
Right. So can we review the configuration? And I just want to showcase everything that a user did not have to touch upon. So if you click on access to do a download Junos config, you can download the Junos config from the UI, and we can review the configuration that was pushed over into the device through the Mist UI. So if you expand that, if you just maximize that screen here, we see all of the underlay configuration. We're using EVPN for your control plane. We're using VXLAN for your data plane. The IRB configuration, IRB/SVI, the routing instances, the policies. A user didn't have to worry about all of that stuff here. If you scroll down to the bottom, we have the VLANs and the VLAN definition. So as a user, for the 80%, 70% use case, do you care about what your VLAN to VNI mapping is? Can we make things so simple that anyone can actually go and spin a fabric? That was our entire agenda. And that's what exactly what we show you here. So we've added one access switch. Now what we're going to do as the second thing is go add another access switch. So this is a day 2 operation, right? Network needs grow, and you want to go add a new access switch. You want to add a new let's say new VLAN. So can you add, Rick, can we create a new network? Let's call it NFD. Let's give it a VLAN ID 200, and let's give it a subnet 200.1.1/0/24. This is the other way of creating networks. The first way we showed you using templates.
And notice how it automatically applies the configuration to both
Right.
devices.
Right.
We
So
will go.
if you click cross on that, and let's hit continue. And we've selected a new access switch here. Let's just cable them up, and life will be good after that, we hope.
We also want to show the connection table that I
Absolutely. So as I was speaking earlier, your devices, let's say, haven't even shipped, right? You've built a campus fabric topology here. What you can do is you can build a fabric here, cable them up, send it to your installers in the wherever your physical network environment, and download a connection table from there. And you can send them this CSV file that basically tells them how to connect the devices.
Perfect for the building the fabric without the systems online. Build the fabric, hand the Excel spreadsheet over to the deployment team, and we're good to go, right?
Absolutely. So now let's look at the Access 1 that we just connected, and let's see if the Access 1, all the configuration that was needed has been applied.
Oh, look at that. That's good timing right
Is
there.
that Access 1 or is that Access 2?
This is Access 2.
This is Access 2. Can we ping from Access 2 to Access 1?
Sure.
We should be able to. Which is desktop 1, by the way, that's connected to Access 1. So it hasn't. Oh, it has come up, and as we can see, it was as seamless as that. Plugging in a access switch at any point, and everything's working at this point, right?
Yep.
So this is Access 1 talking to Access 2. Now we all, of course, spoke about the campus fabric configuration, but it's really important for us to show you how do you actually route to the internet, right? The configuration from the fabric all the way to the WAN or to the firewall. So Rick, can you take us to Core 1 and Core 2 configuration switch detail page? And we want to show, if you scroll down to the BGP section there, we want to show you some UI configuration that we pre-did before we came here. So we have the BGP neighbors here. So if you click on any of them, all of that is built in the UI. The routing policies are built in the UI. Again, this is between the core and the WAN, or the core and the SRX, right? So all of the routing policies are built in there. Everything that we showcased you goes through all the policies there, and yeah, that's pretty much it from a fabric perspective. So you can see the fabric, the entire campus network came up, and this was us building one pod. But Rick, if you take us back to campus fabric there for a second again, I want to show you, you want to build another topology, another fabric, so go to edit configuration, and let's take us to the final step there, in which you basically can span new pods as you'd like. Right, so you can build a new pod, you can build new access switches, and doesn't really require a lot of effort from our perspective.
And quick question on this. Demo's all V4. I heard V6 before. What's the state of V6 in all of this?
V6 is, we're actually relatively good shape with V6. So full underlay support for V6, full overlay support for V6, MLD, a modicum of V6 multicast. That's where we're spending most of our time this year, in V6 multicast.
V6 multicast.
In the overlay.
All right, so standard V6 underlay, V6 overlay,
Yep.
fully supported,
Yep.
and getting some additional capabilities around multicast.
Yes.
Okay.
Yep. Yeah, we're beginning to see much more V6 now in the enterprise, believe it or not. Yeah, I don't know about you guys, but we're beginning to see that.
I wish I was. I can't say I'm seeing the same thing. I wish I was.
Well, I think it depends on the use case, but yes,
Yeah.
we're beginning to see that.
You're able to log in to the command line as well, and you ran some show commands there. Are you also able to modify your configuration at the command line?
Absolutely. So
The recommendation is that you use for all practical purposes, everything that you need is delivered from the cloud. You can do all the show commands, troubleshoot, debugging, trace logs, to name it. The recommendation for you is for you to be able to run all the commands directly on the cloud. The good news is every single switch detail page that you have all the way at the bottom of the screens. Let's say you have a knob that we have not turned on the UI. For example, I think we've given you BFD timers. Let's just say, for example, that you did not have, and you want to implement it. You have a way to push that CLI directly from the UI. So it's still one source of truth. This is primarily run for whenever you're running really large campuses. You can start deviating very easily, and that becomes a very big problem to manage. And maintaining one source of truth is primarily where we're getting to. But you have the option to push whatever CLI you would like to through the UI.
Yep.
I did want to ask that too. If there is a setting that is available in the Mist AI and somebody just goes in and changes the configuration on a switch port, I'm assuming that then that configuration will then reflect in Mist AI that change has been made? Or
Yes. We absolutely tell you we have a way to say that this was CLI driven, and it'll be nice in red for you to see this was not done by you, somebody done from out of band, if you are considering us in band. And that's visible not only on a per switch level, but on a per site level. So you can see which switches are deviating from your standard of config.
And then as a follow-up, can you have remediation policies in Mist AI so you know that you don't want somebody to make a configuration change via the CLI on something? Can you fix that?
Yeah, from a
Just
perspective
RBAC, right?
of administration, we have really granular, RBAC or rollback, sorry, not rollback, role-based policy administration. We also introduced a unique role. Let's say, for example, you wouldn't want people who are just touching your layer 2 switches to change the config on a per port basis to go make changes to the core, for example. There is a unique role, it's called port admin. All they can do is they can go administer ports that are allowed by you as a super admin. Let's say you don't want them to touch the uplink ports, even on the access.
I was going to say that.
Right?
Yeah.
So and this was, again, some of it was our thought process, but most of it is driven by customers saying, I don't want them touching my uplink ports. Yes, I want them access to the access layer, but only to change a VLAN from, a camera port to an AP port, but nothing beyond that. And that's where we get to a granular place to solve the problems that are there in the field.
Yeah,
The changes are synced then from CLI changes to Mist changes.
No, you can do all of the changes directly from the UI. CLI changes are reflected saying there's a change. It should not have been there. And then we'll tell you that there's a problem that needs to be remediated. There's deviation from...
But hold on. What if the deviation was legitimate? So what do you do in the tool? You have this button to accept it or just, kill it?
No, you just do reconfiguration from the UI for it. So let's say whatever config you did, you would want to be administered from the UI, and you want to be able to say the source of truth is merged here, so you reconfigure it from the UI if you think it's legitimate and warranted.
Okay, but suppose somebody does change and it's legitimate once again. So are you able just to take that piece of configuration and add it to your template from that notification, or you just have to go somewhere else and copy and paste, and then the tool will check and now it's good.
Not automated, but you can do it. We'll tell you that this was exactly the line of config change.
Okay.
If you're interested, you can put that into the...
Brilliant. Thank you.
So would it be safe to say once you're managing via the UI, you should no longer go back and configure via
For
CLI?
configuration, yes.
Yep.
That's best practice. That's what we would want to encourage.
Now, what I do, just personally, what I do is if I'm in the UI, I'll throw a config against the device just to see if it works, and then I'll roll it back. So it's for those of us who like that, who like getting into the UI, it does take a little bit of time to pull back and trust Mist, but it is a single source of truth. So everything you could do from a configuration perspective is done through the Mist cloud, everything. And then it could be templatized as well, right? So
to follow up on that, I think my experience has been with a lot of customers that the maturity of their engineering and operations teams is, and there's a certain degree of fear as well of moving from the CLI, that they want both. And so particularly in like a troubleshooting scenario, you end up with some of the situations we've talked about today where a configuration change was made to a device that may have resolved the issue and now is legitimate. But if you're saying we can't essentially accept that I now have to recreate the same change from the UI and push it out, how does that change mechanism take place? Is there any potential downtime now going to be incurred by making that switch from CLI to?
No.
Okay.
No.
So it's non-disruptive in that regard.
Like the same config will be pushed. Junos understand it's the same config. There'll be no.
Yeah, I wanted to add actually after this, because there are some other tools that you have a configuration template and you push it to the device. And the way that they do the changes, that they do something like no config and then they vomit the whole thing again. So then the OS, Junos in this case, is able to do a smart diff and then just put the things that needs, right? It's not that it's going to vomit the whole thing again, and then even if the box will flick for 2 seconds, doesn't matter, but there will be an interruption.
So the good news with us is we go through the process of commit and then commit confirm. Then we don't. The beauty of cloud, you will see one thing is that there was a tiny button called as Configurable Timer under the management section. Let's say we did a configuration, we shot ourselves in the foot and said we put the wrong subnet for your management address. You lost connectivity.
Yeah.
We will bring back those, because we're a true cloud managed switch, right? You should never lose connectivity to the switch, whatever the case may be. We will bring the switch back to you in whatever minutes you said is the configurable timer. By default, it's set to 10. You can change it to 5. 5 minutes later, the switch is back to the cloud. Even though there were mistakes happen, and we'll bring it back and we'll say, configuration failed. With the last config, this was the reason. Can you please fix it so we can push the right one?
Okay, so the way this happens is that the box is gonna, if you have this 2-stage commit system, it means that it's gonna roll back to the previous configuration commit that was working, in which you had reachability to the cloud. It can be 5 minutes, doesn't matter. But that's what you're gonna do then.
Correct.
Awesome. Thank you. I love
If it can't communicate with the cloud, it's going to roll back.
Awesome. I hate that. Oh, let me just add 2 new lines of commands, and suddenly assume you have 1,500 lines of commands, because I have seen this is horrible, especially in VXLAN. We can go over that. And you added probably 2 lines, and then it's going to vomit 1,502 lines of config. So I'm actually going to get only 2 lines.
2 lines, right? That is correct.
Yeah.
So one thing that I want to add, going back to configuration management, is that it is totally up to you if you want the device to be config managed. You can always turn it off, turn it on. The connectivity is never lost to the cloud. And let's say you get into a time where you want to do extensive troubleshooting and you want to make a lot of changes on the device. Turn off the configuration management, do whatever you want with the device. Just know that when you turn it back on, the mist is the source of truth.
Awesome. Now, this config, so the config, the way you push the config, is it using netconf? And which way are you pushing the config towards the box?
Netconf.
Netconf.
Thank you.
So I have a question via Twitter. So one of your competitors uses Lisp to address endpoint mobility. Is that required?
Endpoint mobility for us, it's a part of the BGP transaction. So you can actually see a BGP roam from a wireless. I'm assuming that's the use case that they're talking about. To say there was a roam from VTEP A to VTEP B. How does VTEP B know about that? And VTEP A knows BGP is our Lisp is a controller based again a control plane that sets to actually manage this. We use standards-based EVPN to exactly do the same thing.
So we don't require Lisp.
No, we don't require Lisp.
We just require the standard multi-protocol BGP extensions when MACs move back and forth between locations. Type 2 MACs.
And